Hi everyone. Gives me great pleasure to introduce Ileana. Ileana Barrionuevo is a security researcher and professor at GISSIC. She works as a Senior Advanced GRC at NaranjaX and is a CTF player, bug hunter, and security speaker from Córdoba in Argentina. What she did not say is she won the Payment Village CTF last year, and I'm hugely looking forward to her talk on Android app instrumentation for digital wallet analysis. So this is Google Pay and Apple Pay. Ileana, over to you.
There's no pause. Can you hear me? Yeah. Okay. So, welcome to the village. Welcome to the workshops. Yeah. Well, in this workshop, we'll just talk about different techniques you can use to analyze applications, mobile Android applications, so you can capture information on the fly without requiring the interception of the traffic or requiring static analysis. So we'll use Frida and objection to run different scripts so we can hook different methods and classes and watch and think different arguments and returns from the methods. So you'll use these techniques in your penetration tests, or if you want to bypass protections in payment wallets and other mobile applications. So what is dynamic instrumentation? It's the art of modifying information and capturing and injecting code at runtime while you use the application. So you inject code into the application's memory space, and this allows to focus on specific methods, classes, and different lines of codes. So what's the goal here? Well, to collect data, to leak data, to perform this logging or modify its logic. Well, sometimes you face different challenges when you perform static analysis. So you may find obfuscated code and you cannot understand what the application is doing. So you may have encrypted information and you don't know where to capture or how to process this, how to vulnerate the application. So you can capture in previous steps before the information is encrypted or after it's encrypted, and you can use it by building different scripts to interact with the application. Well, the other thing is manual testing requires recompilation sometimes because you have to decompile the application, modify, make changes. So you can, for example, break the SSL pinning and then recompile and sign the application again. But then with these techniques, you don't need this. Sometimes. There are some exceptions, but well, in payment apps, you can capture specific methods, critical methods related to the flows, the critical business flows, and well, manipulate the process before it goes to the backend. And you don't need to capture the traffic to do this. You can do that too, but you don't need it. Well, this is the whole simple ecosystem on payment wallets. And you have the device, you have the impulse, and the mobile application, and the different components in the backend. And we'll try to manipulate the process between the device, between the application, and the capture of the credit card data. Well, these tools that I mentioned, Frida and objection, are usually used to break the anti-debugging mechanisms or to break the SSL pinning, right? So you may have used it in the past. But then, what if we use these techniques or these tools to replay transactions or to bypass other mechanisms such as biometric authentication. Well, this is a brief list of different flows that you can break with Frida and objection. But we will focus on the modification of the transaction values, the card data before critical processing. What if we try to exfiltrate data to a different server, even if the application has the protections and the encryption for the card data? I didn't mention that you may want to scan this because you'll have all the commands and the steps so you can perform the walkthrough. It requires some installation tools, but you can just follow all the steps in detail. There's a CTF related to this workshop is related to the CTF, so with this workshop you will solve some of the flags. You get some of the flags. Which tools should I install on my computer? Well, you'll need a physical device, Android, or an emulator. You can just use Genymotion or Android Studio. GISSIC to perform just static analysis, but this would help us understand which methods are in the application. You can install them just GISSIC with this command and just go on. Well, ATB, Android Debug Bridge, you can install it with these commands and then just run this to confirm everything's going well. If the command is not recognized, you should check your path to confirm this command is added, right? Well, then obviously you have to connect the device via USB or you have the emulator. And you can verify again ATB devices command to see if the device is detected. I have this one in my case, the emulator. You will find the APK file in the same document that you scanned before in the QR code, so you can download it to interact with. Sorry, thanks. And then with this command you can install the application directly to the phone, either the emulator or the device, the physical device. So when you should use Frida or objection? Well, Frida is prepared for rooted devices, and objection is prepared for both. It works pretty well with so much noise. Well, objection can be used both with rooted and non-rooted. Yeah. So, framework for runtime instrumentation. What you can do with Frida, you can intercept functions, as we mentioned before. You can inject snippets, you can inject a gadget in the application, and you can install the modified application with this gadget too, and that work is done by objection. Well, in your host, you will need Frida tools, but I highly recommend that you check Frida tools version is that one. You'll avoid different issues in the last versions. So, in the device, you should check your architecture and go to GitHub to download the Frida release, which is the Frida server, which is a file that you'll install in the device. So, you will have on one side in your host Frida tools and the Frida core, which is the command that you will run on your computer, and then you'll have the Frida server on your device. So make sure you download the proper Frida server related to your architecture. Okay, well, you should check the Frida version is the same as the one included in Frida tools installed on your computer. This is very important. If not, nothing would work. So, these are the steps. You can follow this in the document that I provided. You should change the permissions of the Frida server file so we can execute this in a rooted device. Yeah? We first push the file to a temporal location in the device, then we change the permissions, and then we run with this command Frida server. In your computer, in your host, you will check the packages installed, the applications, and the one you want to analyze. So, with this command, for example, let's see. I have the wallet installed. Oh, I'm sorry, it's very, very little, very small. I don't know how to. Well, with this command, you will see the PID and the name of the application. You can interact with that name or with the name of the package. So, to get the package name, you should copy this. For example, I list all the packages, but I just grab for the one that I'm interested in. So, this is the whole name that I should use with the commands, with Frida and objection. I will go back so you can see the commands. And then, to open, to run Frida, you can use this command. So, I just run this and have Frida running. Well, I have the wallet, sorry for. This is a vulnerable wallet that is included in the CTF, so I highly recommend you to download the file. Well, some scripts are online, made by the community, and you can use them to, for example, bypass the root checks or bypass the SSL pinning or make the application debuggable, and you can run them with this command, but we don't need them right now. So, just to show you that there's a different way to run scripts. Well, what you can do? Class enumeration in a static way. I just copied this command to, you should copy this. The instructions are in the document that I provide you. Just let me know if you don't have the document right now. And I share the QR code again. But you copy this script that the structure is the same for all the scripts. So if you want to list all the classes that are included in your application that you are running. Sorry, what?
Microphone's not working well. You might just want to go, like, speak super loud, because I don't think anyone.
You cannot. Okay, you cannot. Okay, I will. All right, thank you. So, you should save this piece of code in a file called hook1, for example. You can put a different name if you want. And then you can start the application and running Frida with this script. Yeah? So, I will exit and run hook 1, for example. And now I'm listing all the classes related to the application. We have, on match, we can add logic to do things when we match the class, or on complete, when the listing, or when the matching finishes. So this is very, very interesting, but we can add different methods, different things to capture information, to modify on the fly, to show in the application different information than the one that the customer is watching in the screen on the application. So hook 2 is another example that I included in the document. This is a dynamic way to list the classes. So while you interact with the application and you run Frida, you will see the different methods and classes that are being called. So I will run this. Hook 2. Well, sorry. Now it's dynamic loading. For example, this is the class that was loaded. Now, a different class, and then you can capture all the classes like this. Let's continue. I don't know. Okay. There's a different way to use the scripts inside the console, so you don't want to exit and running again Frida and every time. So, for example, we are going to hook methods related to a particular class, which is, in this case, home activity, but I can choose different classes. So, Control-C, and then this is hook 3. This will drop all the work done by the other script, so we are running one script at a time. And then you'll see all the methods related to that class. Well, hook methods called by the application. We have another example that you have in the document too. And then we are listing all the methods that you can find also if you decompile the application, if you inspect the APK file with GISSIC, which is the tool that I mentioned in the previous slides. Well, you should do this. This is a hint that I give you for the CTF. And you can inspect the different methods and classes and find secret information too. Well, to hook a particular method, we should have done this process of inspecting the application or just listing the methods related to a class. And I just copy the name of the method here, and I put it here. And then, well, I'm just printing information just to show you this is pretty easy. So now, sorry, I don't see the screen very well. Now we are listing and hooking a particular method which is calling different methods as well. So we can have a perspective of the backtrace too. Well, hook 5. For example, what if we want to inspect send money function? while we use the feature. So I will load hook 5 that you have also in file. I'm just listening and waiting for the application interaction so I can just do something. For example, I'm just printing hooked on create, la la la, and I want to print the arguments of the method, of this method. So by doing static analysis, I've just previously seen that these are the different arguments of the function. So I'm just printing that on the terminal, on my host. So just to show you the information. So, for example, if I send money 1, sorry. Now, these methods are invoked. So this is hook 5. Let me, yeah. There are tons of lines. And then, what if I want to manipulate? So we'll see this. I just added more logic. So instead of, imagine you are the attacker and you have compromised the application in some way, and at runtime, you, for example, you can decrease the balance and show the user that the balance is okay. But when the user sends money, you are just sending a different amount of money. So this is hook 6. We'll run it. Sorry. Then we're waiting. Sometimes the application gets back to a different state, but well, if I just stop the process, the Frida process, then the application shows me the login again. I think the network is not so good. It's not working the internet, but okay. Or someone just took down the application, but I don't think so. Okay, let's see if okay, it's not working. I don't know why. Let's see if we can. I don't know what happened. Let's run again. It's not working.
Do you need it for your laptop or for the MPAS?
No, it's the application. Since I don't know what happened, but it was working. But I cannot just log in. I don't know why. It says. I just need that. No, it's an error, I think, because.
No, so it's down for me too. I had to swap out my hotspot, which is right here. So this is. I need Obel to set this up. I can. Just one moment for technical difficulties. Oh, can you hotspot it?
Yeah, but it was connected to this one right now. So I changed
just
it.
hotspot if you can.
Yeah, it's hotspot. This one. Okay, let's see if we can continue with this. I'm sorry. Yeah, it's working right now. So, what I wanted to show you was that, let's go back to the script. Hook 6, sorry. I will just load the script to hook that method. So I'm just listening. I'm just listening for the application interaction. So now I will send money to a different account. Money sent successfully, and now I just printed original amount 1, but then the modified amount was just 2, right? So we are showing the user a different information than the one expected. So this is something exploitable in some wallets. If there's a merchant, for example, interacting with the user, with the customer, and the customer is paying in the MPOS, so different things can be shown to the customer, and then as a merchant, as attackers, we can capture information and use it later, for example. So, objection. Objection is a great tool. Great tool. But it has some disadvantages. For example, it crashes sometimes and the application stops. But it works pretty well. It works with rooted and non-rooted devices, and what it does is it embeds the Frida gadget to the application. It generates a new application with injected Frida gadget, and then you have to install the modified application in the device. And you will interact with this modified application. It automates all the process of injecting the Frida gadget. So you just download objection, and running this command, you have to specify the version, the Frida version, with the one you will work with. Why? Why this? Because objection fails with the latest version of Frida, just because of that. I provide the original application, and then I add some flags. I just want to tell objection to include a new modified network security config that to make the application trust in user certificates, so we can, for example, break SSL pinning to bypass it. Then I add this flag to make the application debuggable, and then, two flag just to specify a version that is needed. But you copy that, and you have a new application available. If the application is rooted, you don't need to patch and create a new application. You just get the process ID, or the process name in this case, and you just run objection. You just run this. I will cut this. And now I have a new console to interact with. But if you patch the application and if you generate a new APK file, when you open the application, it will be blank. But this doesn't mean that it's not working. It just means that it's waiting for you in your computer to connect with objection. So, what can I do? I can do different things. I can just list the directory of the application. I can see the cache files and share prefs to see if there are different things. Right? So I can see if something is hidden on the files, or if there are different logs capturing data in the application. application and with bad practices, with improper practices, for example, I can see different directories. So all of them should be inspected by a pen tester. I can just break the SSL pinning, the root checks, execute some shell commands, for example. If the application is implementing these SSL pinning methods, then this objection console will be waiting for these methods to be invoked, and then the bypass will be performed. In this case, application that I'm using doesn't have SSL pinning, so you can just capture the traffic very, very easy. Well, I can list, I don't need complex scripts here as the ones that I showed you, because some of them are already included here. So Android hooking list activities will bring me the list of activities in the application. Hooking list services, well, this is an example. List receivers, and you can get the current activity you are using, you are interacting with, I mean. So in this case, I'm in the home activity, but if I move to, for example, virtual card, the activity is different, obviously. Okay. I can list all the classes too, list classes, and see the methods related and see if one of them is the one that I want to capture. So, for example, if I just want to list the virtual card activity methods, and I want to list them, just list class methods, and I have the whole list as if I were interacting with the static analysis tool, which is GISSIC. Well, I can run objection and start with a command. For example, if I require to interact with the application without the protections of SSL pinning, well, I just run objection explore with this command. Okay, a job will be created, and you will have this as in a list. So you will have different jobs while you create or run different scripts too. So you can watch for a particular method and see which the arguments are and the returns too. So, for example, let's see, under hooking, just watch. I can just watch the whole class. Well, it sometimes crashes, or a particular method. Yeah. Well, for the challenge, you will have to generate a script based on the examples that I provided in the document. So we can evaluate scripts, we can generate the templates. If I don't know how to generate the different methods in JavaScript for Frida particularly, because these are Frida scripts that you can run them on objection. On objection. So, for example, you can generate templates for a particular class. You will have to do this in the challenge. And, well, it's pretty dark, but you will have different short pieces of code that you have to copy, and then you modify in the middle, you add the logic you want. So, for example, this one is the one that said card in background. You can evaluate if you have the script ready. You can copy the script, and then with this command, evaluate, you paste the script right there. For example, this one. Let's see if it's copy well. Escape and enter. And then it's waiting for me to perform things. Okay. So in this case, I should go to the virtual wallet activity and see if something happens. Well, in this case, it printed out the thing that I added to the method. You can also, you can also modify the balance with these scripts. For example, you copy the proper method and paste it on evaluate. So in this case, in this demo, let me check because there's a flag for the ones that are here in the workshop. So balance bonus. You can import the scripts. You can just import the script, and when you interact with the application, you should see the flag. This flag is not included in the CTF APK. It's just shown here. So make sure you copy that value and enter on the platform. All right. This is a different script to, for example, print the arguments of the virtual card activity method, which is this one. I will copy this just to show you how to do it. And evaluate. Well, something is broken here in the things I copied, but you should modify this logic to modify the balance in the application. For example, what if I do this? What if I just modify what is receiving, what the function is receiving? So let me check. Edit balance. Now we should see a different amount. Well, sometimes application crashes. Well, run out of memory. Okay. In the challenge, you will have to stain the text plain card data. This is a hint, a special hint that is not included in the challenge. So you should capture a specific method from the virtual card activity. Just keep in mind that the information is encrypted. And I think it's pretty difficult to analyze the code and figure out how to decrypt information. So you will have to solve this with Frida or objection. It's the same. Well, these are other methods, other techniques to, for example, inspect the instances related to a class, related to a method, you can just copy and interact with the instances of the application. You just, well, provide the name of the, for example, virtual card activity, which is, well, it's sometimes objection has these errors and the application crashes. It's a drawback. Well, another thing that I hope the objection team improves is the ability to modify in a short way, in a quick way like this one, other methods, because nowadays you have the ability to modify the Boolean returns. But this is interesting. You can download application files, you can upload other files and replace the ones that are in the application. So this is pretty useful if you want to manipulate something. For example, saves in the logs, if you want to manipulate logs, or files used by the application that are required for transactions. You can list the memory modules, you can dump the whole memory of the device, but I warn you that this will crash sometimes the application. So you can just take one part of the memory, you can write the application, and you can search for patterns too. So this is pretty interesting. If you know the database name, you can also interact with the tables and you can take the information from there. Well, other parts in payment applications interesting to manipulate are the QR code tampering, replacing the legitimate QR code. If you're a merchant, as an attacker, you will modify this to redirect the users and pay to a different wallet, for example. You can just capture or get the keys to encrypt information, to encrypt the card data, or you can try to replay transactions. This is real, and we have an example here of 3 similar wallets in Argentina that had this kind of vulnerability, where we initiated the transaction, we make a payment as a merchant, we capture the data, and then if the transaction is accepted, with the information that we capture from the customer, we replace next request with capture data and make other transactions. All of this can be done with Frida and objection. This is more complex, but really exploitable in some vendors because lack of validation in the backends and lack of validation in the impose mechanisms and methods. The SDK was lacking different protections, and it was not following standards like DACT, which is one of the standards used to provide guidance to these transactions. I have this video to show you. For example, I will explain it because it's kind of complex, but we initiate the transaction as a merchant, we force a bad payment, but we are showing the customer the payment failed in the screen because we are just manipulating the whole memory of the device, the whole memory of the application and the object, so we can capture and modify as needed. But in the middle, we capture data, the credit card data, and show the customer it failed. But then we initiate another transaction, telling the customer, please go ahead, put the card again. But we replace the request with the previous data we captured, and then the transaction is accepted, but in this new payment, we capture again more information, new, fresh card information, that when the customer leaves the store, then we'll use this data. So all of this was performed with a simple script, simple Frida script that has been run. So we need to understand how the application works with the static analysis, but we can do all of this just by playing with the objects and arguments and returns of the methods. We just put dummy data in the transactions and show the customer the transaction is failing, but then we are reusing or using information that wasn't used because we save it and show the client, the customer, it fails. Well, you can exfiltrate data to a different server also. This is something that you can use too. But let me show you the process. This is a quick demo. Sorry. This was documents, projects. Okay, I have the demo right here. Let's see if we can. Well, I imported this script that I showed you in the slides. So the script is loaded and we are listening for interaction with the MPOS, with the application as a merchant. So now, I don't know what's going on. Well, now we are interacting with the MPOS and the application, and now we are going to see the information captured after the MPOS encrypted the card data. So this is the track data from the credit cards and the operation ID that we need. Well, these are the tamper info, which is the one that we replaced in the script, so we can make the payment fail. Well, all of this is behind the scenes, but then we are sending previous card data. We are not interacting with the, for example, Burp Suite to capture traffic. I don't need to do that. I can do it just to know the endpoints, for example, but in this stage it's not required. Just to show you that the transactions went well, because the standards were not respected, were not followed. And for example, there was no expiration of the data, and we could reuse data, and that was wrong. Even I don't need to know which the card numbers are, because I just have the encrypted information provided by the MPOS when the customer just tap the card. And just that. So I think I have okay. Summarizing and just to finish, Objection and Frida are great tools, sometimes fail, but they have a lot of potential, and well, you can hook any method, you can manipulate with your scripts, but the limitation I mentioned for Objection is the thing that it's only allowing to modify returns for Boolean. So if the method is returning Booleans, you can modify it on the fly, but it's not quite developed to manipulate other methods to include, for example, strings or return different information that you want. If you want to inspect a payment application, you should think about the business impact, which the critical features are. Sending, receiving money, you can exploit lots of things. The tab, the QR code when you pay. What if you add external cards to the wallet? Entering money from different services, external services. You can do a lot of things there with Objection. Well, this is the key to solve the challenge related to Frida, so pay attention. Reuse of data for transactions shouldn't happen in wallets. Try to break that, because some vendors don't follow the rules. And this is a problem that involves different wallets that use the same device. So, well, questions? I think that's all. But if you have questions, well, I leave you my. I don't know what happened. Thanks. I think this is disconnected because.
Oh, there we go.
There you have my contacts. So thanks for coming. Thanks for everything, and I hope you can take advantage of the tools and solve the challenges.